years of working together between research and practitioners is that collaboration in this area is really important. That's because on the one hand, only the practitioners can see where the real needs are and where the challenges are. And on the other hand, this is still like a very edge area of technology application, and therefore some things are, the newest things are available in research, and it's really interesting to see how they can be applied in practice and how they can drive further development. And finally, sharing experience is really very important, and that's what seminars like this are good for sharing experience among US practitioners, but also sharing experience between US practitioners and us as researchers is very important because it can drive the research in the right directions. And last but not least, nowadays everything is driven by data, and we are really aching to get also data from the use of robots in various real situations, because that's the only thing that can help us to drive the developments further to use artificial intelligence. So now let me go into the actual subject matter. Now you know what I'm going to be trying to tell you. First of all, okay, why use robots in the first place? But I think I can go over this quite quickly because Mark already did the job for me. So I always like to say these 3 points. One is safety, not having to send rescuers into more danger that is necessary, especially when the situations are unpredictable or very uncertain. Extending capabilities, and Mark already gave examples of that. I'll have one more. And sometimes even costs. This technology can actually be cheaper if we disregard the costs that have gone into the previous development. So one example that I want to mention, a very recent one, I suppose that you all know about the fire at Notre Dame in Paris in April 2019. You may or may not know that robots were actually used, both drones and ground robots. The Paris Fire Brigade, I don't think that they had their own trained drone pilots, but they had access to such technology. I think they were using 3 drones to do a global overview of the situation, the kind of thing that Mark was talking about. Interestingly, they also had and used a ground robot, a big tank kind of robot that is able to pull a fire hose and to spray water. So what they did was they sprayed water, the robot sprayed water on the debris that fell off the roof, which was something that definitely could not have been done by people. It would have been too dangerous because it was not clear whether the rest of the building was going to collapse as well. So this was a clear example of, on the one hand, increasing safety, and on the other hand, actually extending capability, because they were able to extinguish fire somewhere where they otherwise would not have been. Here is a closer picture of the robot. It's called Colossus. Another nice example of extending a capability is the fact that with drones, it's possible to make reconnaissance or create an overview of an area of a size which otherwise, with the means that you normally have, is not possible. So you can, a smaller area, you can of course examine on foot, or you can use the turntable ladder for up to, experts are telling me, this is not, oops, oh, okay, that's nice. This is from Fire Brigade Dortmund, actually, who are also who have a drone in their, I would say not every day, but in their standard equipment nowadays. So up to this size, but then there is this gap of capability when the area gets larger, but sort of like not large enough to deploy a standard helicopter. So that's where they are saying, okay, if the area is of about this size, then you have a problem, because from the turntable ladder, you see kind of like this picture at the bottom, so you cannot really see where the heat source is. And whereas when you have a drone, then you can look from the top, and Mark was actually showing similar pictures. And when you have the drone equipped with a thermal camera, then even better, because you can really identify where the fire source or the heat source is, and then plan your measures accordingly. So these are just two examples from real deployments of drones by first responders, added on top of what Mark was already saying. There are actually already drones and ground robots are already used quite a bit. It's just that it's more like sort of until now little really systematic use, but sort of opportunistic. And I have this one slide which is actually borrowed from Robin Murphy, who is a robotics expert in the United States and has been working on robots in disaster response for more than 10 years, more like 15 to 20 years now, and has been really one of the driving forces of carrying out this research and deploying this technology. So according to her, the most common uses of this technology is for search, is for reconnaissance and mapping, and is for structural inspection. And that's kind of also the experience that we have made. As I said, we have been in these projects where end users, practitioners, and researchers have been working together now for some years. Just to pay due diligence, I have this slide here with the partners that have been part of these European projects. And as you can see, okay, we had also one drone and one ground robot company with us. Ascending Technologies do not exist anymore. They have been acquired by Intel 2 or 3 years back now. And we have been working with the fire brigade of the Rotterdam region, with Dortmund, and with the Italian fire brigade. And there, it's good to remark, the Italians have really the advantage of having a centralized organization, and that means that they really have, like, you know, a trained, well-equipped central unit that has all kinds of drones and such like technology, and it's part of their other normal flying units. So that's kind of one model. The complete opposite is in Germany, where every land, or even every bigger city, is on its own. And that, of course, creates a huge problem when it comes to incorporating modern technology, because, yeah, these are costs and beyond that. A little bit to fight this, or to kind of like see how the situation can be improved. Since 2 years back, we have this project that is funded by the German Ministry of Science and Education, and where it's about bundling the capabilities and the experience between end users and research, developing further, but also developing sort of like sustainable capabilities for deploying robots. And I have here I just have it like as a, you know, with whom we have been working and are still working together. So the things that I'm showing here, I have 2 slides at the end specifically about this competence center. So the kind of tasks that we have been trying out in our projects over the last 10 years are what I have listed here. Again, I mean, Mark was already talking about these kind of things. Here we did both drones and ground robots. So mostly drones, providing an overview anytime, continuously during an incident response, carrying out search, especially for victims or for potential hazard sources. Depending on which sensors you mount on the robots, yeah, the robots are just there to move the sensors around, so carrying various kinds of measurements, collecting data for 3D models, and collecting, being able to collect in the sense of really grab samples, and also tactile sensing in cases that there is smoke and stuff where you cannot actually see anything. So those are the kind of examples of missions that we have been playing with, and I thought this time I would try to point out some of the challenges that we have identified. Some of them are not really surprising, things that, like, for example, connectivity, you will have thought of by yourself right away. If you want to teleoperate a robot, you have to have a connection to it. And depending on what kind of environment, what kind of incident you are dealing with, the infrastructure might still be there, or it might be severely damaged, and that's a problem, of course. So one of the topics that is being addressed in the research, in the competence center that we now have in Germany, is connecting various networking technologies in order to create a robust solution that can be used in these kind of situations to actually establish reliable networks without having to grab military technologies that in some cases might be there. So the idea is basically to have a van which comes and makes the network. Another big issue is control interfaces. So the operators who are controlling the robots need situational awareness. The kind of scenarios that we have been looking at, we have mostly been looking into robots going inside somewhere, into damaged buildings or buildings after explosions and stuff like that. So working in some structures that are, for example, unstable, so you don't want to send people there. Now, that means that the operators need to drive the robots through maybe complex indoor environments, and that means that they need situational awareness. Kind of the local one in order to see where they should not go so they don't get stuck, but also a bit more global one, because otherwise they don't know, like, am I on the left, am I on the right of the building, which rooms have I already examined and stuff like that. And that is definitely an area where there is still a lot to be done. The interfaces that we have so far are nowhere good. I have an example here, which is kind of from maybe 2 years ago, what we had at the end of one of the EU projects. Here you have the 3D map that the robot constructs as it goes, with the robot actually projected into it, so it kind of gives you a view like as if you were inside the environment. And here you have the view of the different cameras that the robot is carrying. One camera kind of elevated above the robot platform, and this is a so-called omnidirectional camera, so it has 6 cameras pointing in different directions, and here it's all kind of put into one picture. It takes a bit of getting used to be able to use this at all. And plus, the robot has like many degrees of freedom. So this ground robot, I will have a picture somewhere later which shows it a bit better. When you're driving it over some little bit more complex terrain, then you have to control these so-called flippers, right? And that is another thing. Besides, you need to be looking around in the environment, and that can be quite difficult. So therefore, we are, on the one hand, you need to have an interface to control all of this and see like what you're actually doing, and on the other, it helps there to develop some autonomous assistance functions, and I have that somewhere a little bit later. Now I talked kind of about the local situational awareness of the operator, but also there is the higher tactical level. You all know that the team that is using the robot is not there alone. It's part of a larger structured team that is tackling the incident. And so we have been looking, or are continuously looking, into ways to project the collected information into some kind of one tactical overview that, say, the incident commander can use to plan further steps in the mission and to make decisions. So here's one example where basically there is a Google map on which we project various so-called points of interest, so where there have been victims found or some hazard sources, fire, smoke, etc. And here there are a whole lot of issues, of course, to address, because one of them is the situation changes. So how do you keep track of the changing situation, and how do you present it to the user who is looking at this? So this is again a place where collaboration is needed, because we as researchers, like to dream up a lot of things, but only some of them may be useful, or maybe you need completely different things. So a lot of testing is needed. Currently, we are working on another version of such an interface where actually 3D maps or 3D geo positioning data are being projected into the map. So you basically have these 3D environments, and then again the information collected by the robots is projected into these environments. So far this is only from the outside, not from the inside. Okay, so this is kind of funny, I think. There's one remark that I want to make about kind of the way that such like robot-assisted teams are incorporated into the disaster response. And this is again something that Robin Murphy noticed some time ago, that there is this kind of two modes of use. One, she labeled remote presence, and what she means by that is that the responders are consuming the information from the robots in real time. So you basically use the robot as a remote camera or as a remote, any kind of sensor that is carrying. You're looking at it as you get the information and you make decisions about it. In this case, there seems to be a tendency for the responders really to control the robot themselves so that they can look here, look there, and be very dynamic. Another mode is possible, and that is basically that there is a task that needs to be done, such as collecting data for a 3D model, and then it's possible to basically delegate this to an agency, right? It could even be that it's somebody outside of the first responders organization. It's a company that's very good at flying drones or driving ground robots, and that you say like, you guys come here with us into this incident and do this. And a little bit, this is kind of an option that especially offers itself when you basically want data that you want to use after the actual mission of driving or flying the robot around, such as collecting data for 3D models. And this is kind of what we did in 2016 after the earthquake in Amatrice, where the Italian fire brigade called us to do a mission there to collect data and make 3D models of 2 churches that were heavily damaged in the earthquake. It was an experiment where they basically wanted to see, okay, will this work? Will a researcher team be able to be there within 48 hours? And will they be able to work within the constraints of a serious disaster response situation? And so that was part of kind of it was an experiment kind of along these lines, but at the same time they really wanted to have this data. So we were using 2 ground robots of this kind of middle-sized, can be carried by 2 people easily, equipped with a laser, the omnidirectional camera, another camera on top, with a pen tilt unit and a thermal camera. And we had 1 small, cheap drone, and we had 2 expensive drones with high-quality cameras. Here is one of the churches that was heavily damaged, and the idea was, the wish was to collect data from inside the church in order to create 3D models, not only from outside but also from the inside. The challenge was how to get inside the church. One possibility for the drones was to fly in through the rose window in front, on the front facade. You may be able to see, maybe not, that there was like cables across this window. So this was like a real challenge. And in fact, the very experienced pilots of these more expensive drones did not want to do that. They considered that too high a risk to lose a 20,000 euro worth drone there. So in the end, we decided to, yes, give it a try, but we used a small DJI drone, which we considered expendable at the level of, at that moment, 3,000 euro per piece. The challenge there is the pilot is standing on the ground and has to kind of make it through this hole, which has the barrier in the middle. So it was a pretty difficult maneuver. Succeeded. and the drone could fly inside, which you can see on the video that's running here, right bottom corner, where you basically have the view from the drone looking at one of the ground robots that are moving inside. So we got the ground robots inside the church as well. You can see that on the video here on the left, which was taken by the other ground robot that was already in the church. The robots were entering through a side door. The door is on the top left picture on the left-hand side of the church. There was a door through which there was a lot of stones. So it was good that we had this ground robot that could really traverse the terrain. And was able to enter the church. So the ground robots, they stayed inside the church for about 4 hours, collecting data. It was really difficult driving because, like, we didn't, the guys driving it, they did not know it, right? So what they did was only the view from the cameras of the robot, which I was showing you before, is not particularly good. Or sometimes they were using this possibility of looking from one robot at what the other one is doing. And yeah, the drone operation took about 15 minutes because that's as much as the battery would give us. So yeah, battery life is of course a serious constraint when it takes you, 5 minutes to get inside actually, and then you have 5 minutes flight time, and then you need to use your last 5 minutes to get out again. Okay, so that was one church. Maybe if my thing, yeah, okay, here. I don't actually need the sound. It's a lot of noise, of course. So this is from the other church, but it doesn't go out. Okay. This is from the other church. There the challenge was that, you might think you could easily get in through this front door, which kind of looks open. It was open a little bit, but not much. So it was not an option to go in through the front door. The only option was the hole in the ceiling. But as you can see, that was actually out of line of sight in the sense of it was an opening from the top, but flying you didn't really actually see into it. And on the pictures it looks kind of broad, but it wasn't. It was about like 2 meters broad, if I remember correctly. So just maybe even less than that. So just a little bit more than the drone. So in this case it was really, really difficult maneuver to get the drone inside actually. So this guy in the gray, light gray t-shirt is the pilot of the small drone that was supposed to get inside. And what we did on that occasion was that we actually had this multi-robot collaboration where we were using one of the expensive drones, one of the ascending, to provide an external view. So you can see it on the top right picture here. So there is one drone kind of looking at the hole, and the pilot of the actual drone that is entering is using that view to fly inside. But because he's quite busy looking at the screen of his own drone, then there was one of the guys on the team was basically serving as an assistant. He was continuously looking between the two screens, one screen, other screen, and he was kind of helping to instruct the pilot what to do based on the visual feed from the robot that was giving a third-person perspective. So this was a really interesting kind of collaboration experience, and I think in many, when the situations get a little bit more difficult than just, okay, I fly over a scene and have a continuous overview, when it's about entering difficult structures like this, or some other more complex tasks, then such collaboration is very important. We also observed similar need for having an external view when we were doing a manipulation task. Because when I don't have pictures of that here, like videos, but when you have an arm that's trying to grab something and you only have a camera inside the arm, it's really hard to actually estimate distance and anything. But then we also sometimes used either drone or a ground robot that came near in order to provide a third-person view. So let's see what other, so these missions were full of challenges, but we succeeded and built the 3D models But I think it was even more important what all kinds of things we learned about these missions. So there are a lot of challenges, and you have some of this you have seen also here. So in the middle, I'm kind of showing in what conditions the guys were operating, right? In what conditions the team was. So maybe I'll start from the top as I had intended. During our experiments during the project, we always set up a nice command post, right? Usually inside some container that was available on the premises, monitors, what have you not. Whereas when we got to Amatrice, there was nothing, right? There was a couple of these beer tables and benches, and there was nothing. On another occasion, that was earlier in Mirandola, there was at least a tent. So, for example, sunlight was a real problem. You know that when you get sunlight on your screen, you see nothing. But when you are making this difficult maneuver entering the church, you would like to see something on your screen. So this is how we were improvising, being able to see something on the screens at all. So this is something that needs to be taken into account when planning the mission, like, you know, how do we arrange it? At the end of the project, we actually created a mobile command post inside a mobile container, which in principle one could take to an incident site, but of course you may or may not have the time, the distance may or may not be the right kind of distance, right? We were doing a deployment in central Italy. So there are definitely logistics challenges. During our experiments, we always, transported four different ground robots and several UAVs and a lot of other equipment. So it usually looked something like this: a truck full of stuff that had to be unpacked and packed. You can kind of forget taking all this to an incident site. So that was partly the motivation for making this command post in a container. A side note, which will not be surprising for you, but sometimes we forgot to think about that. We need electricity, right? So there better be generators. So things like that need to be definitely taken into account from a practical point of view. And then there are many kind of many concerns along the lines of, okay, what robots do you use? Or if you're thinking like, okay, well, maybe our fire brigade can get a robot. What robot should it get? Well, there is no answer to this, right? There is no one fits all. So you have different types. We already talked: drones, ground robots, or are you thinking of using them on water or even underwater? Size matters, right? Drones, of course, you have these small, cheap ones. As I said, it's very convenient. Then again, they will not be able to carry much, and they will the cheap commercial ones have what they have, the camera, and you cannot put any other sensors on them. So that's a bit of an issue. As far as ground robots are concerned, again, you can have small, for example, snake-like robots that are really good when you have collapsed structures. They can get into small cavities, but they cannot traverse over, big terrain. And it goes all the way, like we had this kind of medium-sized robot, and it goes all the way to these kind of heavy tank-like robots, like the Colossus in Paris, right? You need a robot of that kind, if you wanted to pull a fire hose. So that I see as a big challenge in creating these kind of robot-equipped units, because you cannot have all that you might ever need. So what are you going to include? And if you need something else, where do you get it from? There are many challenges that kind of are more on the interface to research. So questions that need to be addressed, developing more advanced capabilities of the robots. I have here this really nice video, top right, showing that these robots are capable of traversing quite complex terrain, like after an earthquake. And I already mentioned that it's difficult to get the settings of the robot's flippers right in order to traverse that terrain. But exactly for that, robotics is working on solutions to do that automatically. And in that case, then the robot operator basically just needs to determine the direction, and the robot can take care of itself as far as moving. So that's one example, but there are many others where such like autonomous assistance functions are needed and are intensively being worked on in research. Entering complex or collapsed structures like the churches in Italy that I already mentioned, traversing difficult terrain, or flying in difficult conditions in wind, or when you are flying inside like a chimney, there you have complex turbulences that are difficult to handle manually. So again, if the robot can be more autonomous there, it's really, really useful. I already mentioned grasping objects. Here we had an experiment where we were trying to plug a barrel, teleoperated, and it really was a bit of a challenge. So these kind of things are being worked on, and again are cases where it's really important that research and practitioners work together, because we need to determine what the challenges are. Mark talked about drones, and even about autonomous ones that are stationed and go by themselves to an incident site. Here's another example, actually something that was developed based on the experience in Amatrice. Namely, when you want to use a drone in order to collect data for building a 3D map, the quality of the data you collect, so you basically take individual pictures, right? And then you have software that puts it together and creates the model. The better you collect those pictures, the better your models are going to be. And therefore, it's actually an art to collect the pictures correctly. And so for that, we created a pipeline which enables you to plan a data collection mission, and then the drone can fly autonomously, and then you have assurance that you are collecting the data right in order to create a high-quality model. There is a YouTube video, of course. So I think a final capability that's my favorite, because this is actually my area of work, is supporting teamwork. And I have been showing you that ultimately these teams are actually quite complex, and there is a lot of communication going on. Now, the robots, they don't know anything about that, right? The robots are like tools. They're like hammers or your cutters or something. They don't have any information about what you're actually doing, what you are doing it for, what you want to achieve. And that is something that we want to change. And how we want to change it is that we are listening to what the people in the mission are talking about, what commands they are giving, what information they are sharing about what the situation is, and from that we extract what are the goals, what is the status of the mission, and we use this on the one hand to support situational awareness so that everybody knows, everybody who needs to know gets the relevant information, but also to provide assistance such as reminding of tasks that should be done. Say when a point of interest is found, then to share a picture with the leader of the mission. And after the mission, creating documentation and using this information possibly also for training, for education. So that's kind of what we are working on. And last comment, I already mentioned at the beginning that these efforts are continued and are being considered important in Germany. And they considered it so important that they decided that it was worth creating this so-called competence center for rescue robotics, which is now currently it's a 4-year project. We are now in the middle of the 2nd year, and if things go well, then it will be extended for another 4 years. So actually, quite some interesting stuff could come out of that. And it's a collaboration between practitioners and research. As I said, on the one hand, to bundle competences, but on the other hand, also to support adoption, to help practitioners to solve those issues that are in the way, such as also things like have already been talked about, certification and the regulations and issues like that, and all with the ultimate vision of contributing to creating a real incident capacities, also in the context of international efforts. So part of the competence center really is focused on these practitioner issues, and the other part is concerned with the technology research topics like those that I just mentioned, in order to be able to advance the technology. Here is the list of partners and associated partners, just to show that we are kind of trying to collaborate with about anybody who has anything to do with that. On the other hand, I mean, there actually is a non-profit organization that was founded as a carrier of these activities, and it is open to members from elsewhere, including internationally. I never understood why we decided to call ourselves a German center, because we explicitly want to be open internationally. So if anybody has interest, then do come and talk to me, and I'm most happy to tell you about it and how you could potentially become members. So to summarize and finish, robots can indeed improve disaster response. And there is already years of experience from exercises, but also from real deployments, and this experience is growing, especially in the case of drones. There are many challenges for robotics, and there is research in progress looking at those. And I said 10 times already that collaboration and sharing experience, I think, is really key, because it's quite difficult to acquire this experience to begin with. And we as researchers would really need data, so if there's anybody who is using robots and is willing to look into ways that mission data could be collected and shared, that would be really interesting. So yeah, thank you for your attention.